Let's pick up where we left off on working with graphs of functions. So one thing we need to be able to determine is, given a graph, does it represent a function or not? It's really simple. We're going to use something called the vertical line test. The vertical line test states if any vertical line drawn through a graph intersects that graph in more than one point, the graph does not define y as a function of x. Real simple. Just draw some vertical lines. Notice each of these vertical lines cross that graph at only one spot. So this one is a function. Notice a vertical line crosses at two spots, so it is not a function. Here, crosses at many points. Not a function. And finally, this line passes the vertical line test. Yes, it is a function. So, simple test. Okay, when we're working with functions, we're going to want to find zeros. And so the zero of a function is just the x-intercept, or it's basically where f of x is equal to 0, where the y value is equal to 0. We could also say where y is equal to 0. So if I wanted to find zeros for any of the functions I'm working with, all I have to do is set that function equal 0. So let's take a look. Let's look at A. I've got the function f of x equals 3x squared plus x minus 10. And to find the zeros, I'm going to set that equal to 0. What I notice about this equation, this resulting equation, is that it's a quadratic. And so we have to pull out our tools for working with quadratic equations. And if you recall, because it's a square, it's going to have two answers. And we'll solve this by factoring. One method of solving a quadratic is by factoring. So recalling factoring skills, we're going to set up two binomials, and in the front positions, those two guys must multiply out to give you a 3x squared. So it's like the FOIL method going backwards. I'm going to split that up into a 3x times an x. These last positions have to multiply out to give me a negative 10. So the two numbers I could multiply to get a 10 would be a 5 and a 2. Now, it depends on the position, the position of those numbers is very important. The reason I put the 5 first and the 2 second is because my mind was thinking, okay, this is a backwards FOIL method. So, when you FOIL something out, you multiply the first two, 3x squared, the outside, 3x times 2 would be a 6x, the insides, a 5x, and the last, 5 times 2 is 10. So I was thinking about FOILing these two binomials out. That's why I put the 5 first and the 2 second, because I noticed a 6x and a 5x, if the 6x was positive and the 5x was negative, they would add up to give me a 1x, which is what I want. And they would multiply to give me a negative 10. Or they should multiply to give me a negative 10. So I need a positive 6, which means the 2 has to be positive. I need a negative 5. The 5 has to be negative. And then I have the complete factorization. Now, you may have learned factoring a different way, but this is one way that you can work with factoring a quadratic. And once you have that quadratic factored, do you remember what you do next? You set each factor to 0. Set 3x minus 5 equals 0, set x plus 2 equals 0, and solve it. So to solve this for x, I'll take the 5 over, divide by 3, and I get an answer of 5/3. That is one of my zeros. When I solve this for x, all I have to do is subtract 2 on the other side, and that's my other zero. So this particular equation has 2 zeros. Let's look at b. I want to find the zeros of that function, so I'm going to set it equal to 0. So I'm going to set g of x equals 0. So it's the square root of 10 minus x squared, set it equal to 0. Now this is an equation that has a square root in it. So how do I remove the square root to solve for x? Well, I do its inverse. If I square both sides, squaring the square root gets rid of that square root symbol, and I'm left with 10 minus x squared. And that's just equal to 0 because we have 0 squared. Now this one turns into another quadratic. So to solve this quadratic, it doesn't have this middle term, so I can use what we call the square root method. I'll take the x squared on the other side to get 10 equal x squared. And the square root method says when you have something squared equal to a constant, you can square root both sides, but when you do, you must put in the plus or minus. So right now, we're just kind of reviewing some ways to solve quadratic equations. How do you know if an equation is quadratic? If it has that square. It means you're going to get 2 answers. We got 2 answers for this quadratic. We're going to get 2 answers for this one. One being a plus square root of 10, and one being a minus square root of 10. Those are our 2 zeros. Finally, part C. I'm going to take h of t and set it equal 0. So 2t minus 3 over t plus 5 is equal to 0. Now this is a fraction. And just a quick note, whenever you have a fraction, the only way a fraction is going to be equal to 0 is if the numerator is equal to 0. We can't ever have a denominator equal 0, so the only time a fraction can be equal to 0 is if the numerator is equal to 0. So I'll take the 2t minus 3, set it equal 0, and solve it for t. So I take the 3 over, divide by 2, and the 0 for this function, one value of 3/2. So remember, these zeros, another name for these zeros, are x-intercepts. So this is where the graph crosses the x-axis. This is an x-intercept. This is an x-intercept. These are x-intercepts. This is an x-intercept. Now, let's put these in our calculator to show that these are indeed the x-intercepts. Okay, let's work on graphing those. So we'll get some good graphing calculator skills by graphing these functions. So the first one is y equal 3x squared plus x minus 10. So we're going to go to y equals. We're going to type this in, 3. We get the x from this button, x. I can use my caret to make it a square. I need to drop it down, so I'll use this arrow key. So 3x squared plus x, and then minus 10. Oops, I lost a 0. Okay, so to get your x, you're going to use this button here next to alpha. I could have did the square using this button, but I just chose to use the caret. And now to graph it, I first want to put my window in the standard window, so I'm going to click zoom, and I want 6, zoom standard. That kind of standardizes your window and gives you a picture of it. Notice this guy is a parabola, and it crosses the x-axis at 2 spots, which is what we found out when we worked on the x-intercepts, or the zeros. So I've got a 0 right here looks like it's negative 2, and I've got a 0 right there. Looks like it's between 1 and 2. So a 0 of negative 2 and an x-intercept between these two guys. Let me show you a way to set up your calculator. I want you to go to this table, second graph, and go to the table. Now, if you scroll, you should be able to see these x-intercepts. See, right there, negative 2, 0, that's your 0 or your x-intercept. The other one was at, I think it was 5/3. We probably won't see that one on here because, oh no, this is where I want to go. Because it's a fraction, and a lot of these won't show up on your calculator, but you will notice whenever you have a change in signs on these y values, that means there's a 0 between those two. It crossed the x-axis. So 5/3 is between 1.5 and 2. I'd like you to do your table setup. Let me find my table set. Where the heck is it? Here it is, right on top of, good grief, can I even read that? Yes, table set on top of window. Second window and go to table set. You can have it start wherever, but I would like you to have this delta table set up at 0.5. That way it's going to give you all the half marks on your table. So with your table set up that way and going to Zoom 6, you get your graph, and if I go to second and graph, I can look at my table and see if those x-intercepts kind of line up with what I found. So let's graph the other one. Let's clear this one out, and we're going to do second x squared to get the square root. And I'm going to type in, let's see, pull it up just a little bit, 10 minus x, and I'll just use the x squared button. Now, if your calculator doesn't show you that elongated square root symbol, you're going to have to type in parentheses. So it would be the square root, parenthesis, 10 minus x squared, and close that parenthesis. Let's go ahead and graph it. So you notice it's kind of this semicircular figure. The x-intercept would occur here and here, and they actually are at square root of 10 and a negative square root of 10, those values we found earlier. You can go to your table, but you won't see them because the square root of 10 is an irrational number. But we could see that it's somewhere around -3 and then somewhere around +3. So a little bit beyond those. Okay, the other graph. Let's clear that out and let's type in a fraction. So for my fraction, I'm going to do a parenthesis, 2x minus 3, close it, divided by, open your parenthesis, x plus 5. When you're doing rational functions like this, you need to enclose the numerator in parentheses as well as the denominator. Let's graph it. And right here is our 0 or our x-intercept. It's where it crosses the x-axis. And if I go to my table, aha, there it is. 1.5, 0. Remember, we obtained a 3/2 when we worked that one out by hand. So here's a way we can just check our work using our calculator. I'll stop this video here and pick up with the next video here with this information.